Given this differential equation, what you're supposed to see there is that this is in the standard form of x y plus n xy multiplied by dy over dx. So we can tell we have m with that, n will correspond with that. So if in that case, let us check the exactness. We can test. We're supposed to have that the partial derivative of m with respective to y must be equals to the partial derivative of n with respective to x. If this takes place, we can be satisfied that this is exact. So then let us try and test that. Let's test this and check. So we have here the partial, we have m x y will be equals to cos x plus y there. All right, then we can take the partial derivative of m with respective to y. We'll have this will be negative sine x plus y. So we can come again and test. We have n. We have again n. On the partial derivative of n, we have n xy. What is that? We have there on the top is 3y squared plus that. All right, we'll have that 3y squared plus 2y plus cos x plus y. This is what we have. So we'll take the partial derivative of n with respective to x, then take the partial derivative with respective to x. This will simply just be a constant. We'll have 0. This will be plus again 0. Then here we're left with that. That will be negative sine x plus y. So this is the same. Therefore, as you can see, the partial derivative there of n with respective to x simply equals to minus sine x plus y. So we have one and the same thing here. All right, we have tested now. Let's try and see. We must know, since we have tested that, we must know that u, I like to say u, this is the formula I often use, will be equals to the integral of m dx. Will be differentiated in terms of what? Of dx. We'll have dx there plus there'll be have some function of, I can say some function of y there. Will have some function of y plus some function of y plus some function of y. But we must know that provided that u is equals to c. Remember, u is simply, I can write that, remember cu, it's the same, is simply just the same as u x y, right? So it's one and the same thing. Let me just write that u. So we know that u x y must be equals to 0. Also u x y must be equals to what? To c. whereby we know again d or u over dy must be equals to our n. From these three, we can find our c there. We can solve using that information there. We can solve using this information there. So we have there u is equals to the integral there. What is this? We have there on the top part, we'll check m. What is m? There we have m. Here it is, will be equals to cos x plus y. All right, we have now there. I can replace that with cos x plus y, supposed to dx multiplied by dx here plus some function of y. All right, plus some function of y. We have u, then we take the derivative of this. We'll simply derivative of cos. Then we'll simply have this will be positive sine x plus y plus some function of k, some function of y. Then we have that u. However, we said let us take the partial, we said the partial derivative of u, or the derivative of u with respect to y must be equals to n. So we can take the derivative of u with respect to y. Right, supposed to take that with respect to y. We take that. Take this will be positive. Partial derivative of sine will simply become cos, will be positive cos. We'll have x plus y. Then the derivative of this will simply equals to k prime of y. That is what we'll have there. But we know this, we have said this is equals to n. So this will be equals to what? To n. What is n? That will be equals to what? To n. What is n? N is all of this. This is our n there. We have n 3y squared plus 2y plus cos x plus 19 plus y. There we have that. So this will be equals to, we've seen that is 3y squared plus 2y plus cos x plus y. We have plus y there. So we can tell from here, we can use inspection, we can tell from inspection, we can see if this cos x plus y, we have cos x plus y this side. It clearly shows that k prime of y must be equals to this guy, 3y squared plus 2y, like that, must be equals to that, we can tell there. So we have to take the derivative there. we have to take inside derivative of that again. We have to take that with respective to what? With respective to y. So we'll take inside derivative of k or y respective to what? To y must be equals to, take again the derivative of 3y squared plus 2y dy. So this guy will simply equals to ky. Then we take the inside derivative of what? Of 3y squared will simply equals to y raised to the power of 3 plus y squared there plus some constant c there plus some c. We have that c there. So we have this, our y to be equals to that, our k, some function of y to be equals to that. But initially here we have that, some function of y here. We can substitute back here on our, we can substitute back there. So if I grab that, we said initially we had that u to be equals to sine x plus y plus some function of y. This is what we had there. So I'll simply take this and put there, substitute there. So we should get that u will be equals to sine x plus y plus, now we substitute, there will be y raised to the power of what? Of 3 plus y raised to the power of 2, right? Wow, plus that. But now we've said, remember this is simply just u, it's the same as u x y. We have said this is equals to what? To c. We have said is equals to c. So then we have this, we have c to be equals to sine x plus y cubed plus y squared. So this is what we have there. This is what we have. So this is what we'll get implicit, sort of like implicit. This is what you'll obtain there.